Welcome to the very first programming task of our physics series, right? Physics 2 series, right? Course our name of our course is Physics 2, right? Okay. So now first task is going to be plot the particle moving with constant velocity. We want to draw the graph of a position versus time of the particle moving with constant velocity. So now what we are going to do is to import the library of Python numpy as np. Second, what we are going to import matplotlib. Matplotlib is the library of Python which helps us to draw the graphs, right? PLT, right? As PLT, what it means that I am giving it just a nickname, right? Okay. I am going to write x0 is equals to 0. What it means that the initial particle starts moving with constant velocity from point x0. Now v is equals to 5. What it means that particle is moving with the velocity 5, right? So now what I am going to create t values. T is equals to np dot line space, and I am going to write here 0, 10 and 100. What it means, it gives us values. Here 100 means 100 values. It is going to return us 100 values between. It is going to return us 100 values between 0 and 10. So what I did, you can see it as an array of 0 to 10, array of 100 values between 0 to 10. So this is an array, you can say. And x is equals to x naught plus v into t. This is, you already know that if the particle is moving with a constant velocity, then its position at any time t is given by x is equals to x naught plus vt. X naught is the point where time is equals to 0, right? So now I am going to plot ELT dot plot. This is the function we used. What we want to plot x and t, right? You must understand we want to print x and t. I am going to write here t and x also I can write. I'm going to show you different variation. If I write plt dot plot t and x, and I am right here plt dot so, and if I shift enter and whatever numpy, okay, numpy is the name of the variable. Shift enter if I, so this is the straight line, right? Because particle moving with a constant velocity, the graph of x versus t of that particle is going to be the straight line. Okay, so now let x of 0 is equals to 3, and if I rerun this, then I'm going to get this graph. And if I write x of 0 is equals to 10, so I'm getting this graph, right? I'm going to write 3 over here. So whatever is changing, you have noticed something that 50, 40, 30, 20 and 10. When I change x naught over here, and if I write 10 here, you can notice position of 10. Now if I rerun, and you can position of 10 is slightly below. So this is changing in our graph. And if I write over here 100, what it means that it is going to give us 100 values between 0 to 100. So this is the array of, you can see an array of 100 values between 0 to 100. And if I shift enter, this shows us the graph of the particle moving with the constant velocity between 0 to 100 seconds. So this is 100. And what thing next we are going to do? We want to give a title. We want to write here that this is the x value and this is the time values, right? So what we can write, plt docs dot x label, and I can write here which label I want to give you. X label is time, right? And we can also give plt dot y label, and I'm going to write here position. Better if I write location, and if I rerun this program, plt.y label spelling is wrong. Okay, plt.y label. So you can see here is the label of position, and here is the label of time, right? So this is how you can uh, simulate. You can draw a graph of the particle moving with constant velocity. We are plotting this function, right? So now we are going to draw a graph of particle under constant acceleration. Okay, so we are going few things are the same. What we are going to import the numpy as np and x0, and we know we can't declare v because the particle is accelerating, right? So if we know the initial velocity, and initial velocity of the particle is 3, and let's say particle is moving with acceleration 2, right? Now what we are going to do, we are going to create time values, and we are going to create 100 time values between 0 to 10 and 100. You may know that 100 time values between 0 to 10. This is you already know. So I'm going to declare x is equals to x naught plus initial velocity plus half. I'm going to write here 0.5 into a into right here t. This equation you already know that if particle moves with constant acceleration, then equation of its motion given by this thing, right? Okay. So what we are going to do, plt dot plot x. Now previously particle is moving with a constant velocity, function is this. Now particle is moving with constant acceleration, function is this. So we want to plot t and x, right? So now, and I am going to plt dot show, and if I shift enter and okay, I must write np dot line space, right? And if I enter, you can see the particle is some type of parabola, because you can see a t square term over here, right? So t square term, what it means that the graph will be somehow parabola, right? Okay. Now I also want to give label to x and y axis. I can write x label, and I can write here uh, time. I can also give title. I am going to give y label as position. Particle is moving in a straight line, that you already know, I think. Plt dot title, and I'm going to give here article under constant acceleration. And if I shift enter, you can see here is the label, particle is moving under constant acceleration. We got time between 0 to 10, and we found 100 values between 0 to 10, and for that 100 values we found the value of x and plotted them here, right? Okay, so this is the graph of particle moving with constant acceleration. Now that's enough for this lecture. We are planning to organize another lecture based on our first lecture of the motion in one dimension. That lecture will slightly advanced lecture, right? Okay, so that's enough for that. Thank you.